In this session, let us begin with a review of what we have learned in the last video. We have completed estimation of mean from ungrouped data and got introduced to estimation of mean from grouped data. You know, mean is calculated by summing all the values in the data set and dividing by the number of values in the data. It represents the average or central value of the data set. The formula to find the mean from ungrouped data is very simple, sigma x by n. The mean of grouped data is calculated by multiplying each class midpoint by its frequency, summing these products and dividing by the total frequency. It estimates the data set's average. So, from grouped data, mean is estimated with a slightly modified formula, sigma fx by n. Now, we will continue with the learning on mean from grouped data. Let me continue with mean from grouped data. Calculating the mean from ungrouped data involves few steps to ensure accuracy and relevance. Initially, the data must be organized into intervals or classes, each representing a range of values. The midpoint of each interval serves as a representative value for that class. This process ensures that the mean represents the central tendency of the data accurately. Once the intervals are determined, the next step involves assigning frequencies to each class, indicating how many data points fall within each class interval. This step is very crucial for weighing the impact of each interval on the overall mean calculation accurately. Each midpoint is then multiplied by its corresponding frequency, reflecting the contribution of that class to the data's overall average. After obtaining the products for all classes, these values are summed together. This cumulative sum represents the combined contribution of all intervals to the data's total value. Finally, to determine the mean, this sum is divided by the total number of values in the data set. This method ensures that each class's contribution to the mean is proportional to its frequency and the midpoint's representativeness. However, challenges may arise, particularly when dealing with large data sets or intervals with varying widths. In such cases, careful attention must be paid to ensure accurate midpoint calculation and frequency assignment to avoid biases in the mean calculation. Overall, while calculating the mean from ungrouped data offers valuable insights into the data's central tendency, it requires careful consideration of interval selection and frequency assignment to ensure accurate interpretation and meaningful analysis is done. We will now work out a problem on estimation of mean from grouped data. This is a problem statement. The frequency distribution below represents the time in seconds needed to serve a sample of customers by cashiers at Bullseye Discount Store in December 1996. This is the data are presented in class intervals, is grouped data. So, I will just make a description of the values in the table. 20 to 30 seconds were taken by 6 cashiers to serve the customers, and 30 to 40 seconds were taken by 16 customers to serve, and 40 to 50 seconds were taken by 21 customers. So, this is how the description of the other values in the table goes. Now, we have to find out the mean time in seconds taken by cashiers at Bullseye Discount Store. Since this data are presented in class intervals or the data are grouped data, you have to first find out the midpoint of each class interval. So, that becomes your x. You may remember that if the data are presented in grouped form or in class intervals, the x values have to be determined from each class interval, and each x value has to be multiplied by its corresponding frequency, and then you find this factor f x. You add up the values of fx, that becomes your sigma fx, which falls in the numerator, and then you determine the mean by dividing sigma fx by the total number of values in the distribution.